Okay, let's get started. Okay, close that. Okay, let's go land. Okay, so where are we now? I think we have enough to build this. Although source is still something that I'm not sure is correct. So let's go take a look. We've got our metadata service. Our metadata service exposes the endpoints to go find excuse me, metadata in our database. There is a query object that we pass in and some convenience functions that just perform a query based on that metadata object. Yesterday we added a find by ID because we need to get back to a specific image at some point in the future. So let's go back to image. So one of the things that's happening here is we've got concepts like location, which are both in the metadata service and in the image. So I think what I'd like to try today is pushing the data access layer into its own its own package. So let's see if there's a refactoring. Okay. Okay, let's go take a look and see if it renamed these appropriately. Yeah, it did. Okay, so let's move file service. Whoops. DB wrapper, file service need to go in there as well. Okay, where are these underlined? Create test DB caller. Okay, so this goes in there as well. Okay, we're just going to be fixing a few of these. That's it. Okay. So that's good, that's good, that's good. Let's see if we can run. Let's see, get rid of the pattern. All right, so we get passing. All right, so now we've isolated off some of the visual noise, and we can focus on model layer where we talk about images. Okay, so let's create our test file. Okay, so image test. So going back to image, we have this as an interface because as we test other stuff, we want to make that mockable, right? Okay, let's also close all these files that we don't need. So we need to make that mockable, but that does mean we need a concrete instance of it, right? So we should create type standard. We call this the data image repository. Don't love the name, but we'll go for that for now. And it needs to have two methods. Find okay, and open. Actually, let's hold off on open for a while. I'm not even sure it belongs there. So we do need find, right? That is definitely a thing we need. Okay. Okay. So start out with a function. In fact, before we do this, we probably need a function like func new image repository. And it's okay to take a reference dependency on something on the next level down in the layer cake, and just because we haven't looked at it for a day or so, let's take a look at the layer cake and ooh and ah. I'm really clicking my mouth this morning. It's annoying. So the layer cake database, this is Postgres. Data access layer, this is the layer that abstracts the querying in and out of the database. And of course it's fine for this to take a dependency on the database layer, right? The logic layer then sits on top of the data access layer, and it's fine for it to take a dependency on that. So I don't view it as a problem of that our system takes that dependency. What I don't like about it is I've got it in a different package, but that's fine. Let's go with that for now. So it's going to take a metadata service data dot server, and it returns return oh, gotta tell it returns a data image returns an image repository, right? So at this level, we know it's going to take a data, we know it's going to take an image repository, and it will return a data image repository. So we actually have a test function before this, which is func test new image repository. Image repository. Let's have type struct type mock metadata server, and it implements the methods of metadata server. And here are our methods. And return nil. Let's just go ahead and copy and paste these in front of everything. And all of these will return nil, nil, right? So they're all going to return nil. And we have to fix up the packaging on this a little bit. Okay. So all these things return nil. And new image repository. And we're going to pass it a mock metadata server. And we're going to cast this back to a we're going to cast this back to a image repository. We're going to pass it back to a data image repository. So we are okay. Actually, at this point we can call fatal, because if we don't have the appropriate casting, we can't test the structure of that value. That's good coffee. So let's go ahead and say expected to cast to data image repository, and if dir dot so it's definitely a data image repository. Data image repository should have a metadata service inside of it, right? So yeah, so if we run this, we'll find that it doesn't have a one of those inside it, right? Let's go back to image. Simple. Let's go back to image. And inside of image, we just need to set the metadata server, right? Now we're on the test. It passes. Okay, good. Now let's do this one. So IR and IR dot find and what do we want for query parameters? Actually, it's fine. Just empty query parameters. Find everything. Find. So that's what we should expect. Error not equals nil. Game over, right? So at this point we can do a T fatal. Because we can't really test anything else further down if that's the case, right? So I'm going to you know what, I'm just going to have a results. Send return error. Actually, let's do this. Let's make that an error. Okay. So images, find QP. And let's make these all return results. Let's make these all the same. Let's make this single. And single. There we go. Now everything's happy, right? So let's take a look here. Images equals error find. Okay, if error is nil, let's put in some results. So we called it results. And we're going to put an array of metadata, and this is going to be one. What other things can I put in here? I can put in a date. I can put in a location. Add some tags. And I can add a locator. I'm just slice of locators, which in this case will be a slice of locators. And that means I need to be able to mock those out as well, so I will have mock locator what are my methods on locator? Fantastic. So we'll just add a couple of silly methods here. And return. We need to return, let's return nil for now. Okay, so we've got a few of those. Mock locator. Okay, let's see what's going on here. Why can't I use it as a locator? Okay, that's the way I would do it. Okay. All right, so let's just return a couple more of these. Yeah, these are different ones. All right. So what are we testing here? We are testing what are we testing here? What are we testing here? Let's make this one work. This one Baz Quux. Okay, okay, let's start with a simple test first. It's not really going to be that interesting until we get down further, I think. We will need to implement some logic in the mock data server to return a result based on an actual query kind of thing. Expected okay. So if we run this, it should fail. Okay, great. Okay. This should ask metadata server. Interesting. We need a context, right? And so what do we know about the context? The context is going to be cancelable from where? From really the web front end, right? So some web operation is going to abort, and that's going to cause a cancel to come through. It's going to come through our layer cake. So we expect cancellations to originate somewhere in here and propagate down. So trying to think of a good example. Maybe we have some sort of WebSocket. The WebSocket is closed, so the server interface layer sends a cancel on an existing query. It propagates down. So yes, this layer still needs to take a context. So let's take a look at the image repository, and let's go ahead and add a context. Context is one of those things that feels a little anti-patternish when you see the context being passed through layer after layer after layer. But at the same time, it is one of those things that we can, like in Java, you can pull out a request scope from the dependency injection. But it's essentially a nice way of passing that information down from call to call to call, right? It's set up a little bit different in the thread local storage, I believe, but at the end of the day, what they're really doing is the same thing that we're doing with context. They're just making it, I guess, prettier and nicer. So we need to pass it a context and a metadata query. Let's go ahead and pass it a metadata query for everything. And that returns back metadata. All right. If error not equals nil, return nil error. Right, okay. So now we have metadata safe in hand. And we're going to return images. So for M result, and this is going to be a type of image, and we are going to make as many as we have metadata, right? Equals range. Oh, we want to do it by index. Okay. So image, and what are the things that we're going to have in the image? The image, right, is Oh, that's image test. So the image is the ID, the date, the tags, the sources. The ID, okay, and then for L range metadata I dot locator. Well, first things first. Result sources Okay, for all the locators, ah, equals, how do I define sources? Let's take a look at how I define sources. So how do I define source? Source is name, location, okay. Name would be metadata I dot locator L dot okay. Return result. Okay. Let's go back to our test. Oops. my confusing languages here. Index out of range 1 with length 1 recovered. Okay, let's go take a look. It's probably in here if we have an error. That's my guess. Okay. All right. Okay, so we need to address this problem area. So what's the source is about where an image lives, right? So what we have here is the metadata service. The metadata service is pulling back information from the metadata table about the image. The locator table has 4 columns. It has a source and a path. So if we go take a look at this table, the source is a file source. So if I were going to go back to metadata service, and let's actually move locator in its own thing. Okay. All right, so now we have locator in its own thing. Let's go to metadata service test. Do we test anything in the locator? I don't think we have any locator tests because the locator does absolutely nothing at this point. In fact, if I were to go and say find me anything or saw locator, I have 43 references. In fact, I know it would be called test locate. Nope, no tests for locator. Okay. So I've got this thing called locator, and source is a string, and I've got a file locator, a file path, indicates the source indicates the type of location, e.g. files. Do we call it file or files? Is a file on the file system. Opens a retrieve the. So data opens a stream to retrieve the contents of the image at that location. Okay. Would I know the name here? So let's think about this. Let's think about this being a file in the file system. It's the easiest case. What's the name? The name is going to be the file name, and that's just going to be the last part of the path. That's a no-brainer. That may not necessarily be true in something like an API, right? So an API might return back, you know, might have a tail on the end of it like ID equals 1, 2, 3, 4. That is not the file name. Hmm. It's not the same thing as the metadata, right? The metadata is so the metadata is let's be clear about this, for each media may have multiple copies at each of the given locations. So in this case, for example, we have a JPEG file off the file system. The same JPEG exists in another directory, and at a bucket in AWS. Okay, so the locator allows me to go to a metadata. Now, file is a slightly different concept. So, I'm sorry, image. No, I should just get rid of these. These make no sense right now. Okay, image. Image does what? Image indicates that this so let's talk about this. For example, I have a JPEG on the local file system. I have another copy in AWS, and I have a thumbnail in API, and they all reference the same image. So this is my vision for image. I could have a TIFF on the local file system. I have another copy as a JPEG. So yes, so this is the concept I have for image. Image is, I took a picture of a cat on a Tuesday afternoon in 2019. So it's image number 1234. I've conflated two things here. Okay, I see. I've conflated two things. I've conflated the notion of the representation. Well, no, this was all supposed to be the original image. So I took the picture of the cat in 2019 on a Tuesday, and then in 2020, I made a thumbnail of it. The thumbnail and the original image both have the same time that they were first captured. They both have the same subjects. They were both taken at the same location. They both have a description, but they have two different sources. So the source should probably not be named location. The source would probably something be like definitely location. Well, maybe it's really a URI. Maybe this is really meant to be a URI. So location's a URL. Now what else could we want to know about this? We could want resolution. And how would we represent resolution? That seems reasonable. A resolution is a pair of integers for the x and the y. I don't love that. Can I do that? Is that kosher? If I put them in the right order, is it kosher? Let's call it width and height. Okay, let's we have an encoding, and that's pretty much a string, right? Because, well, we've got a certain number. Well, no, we could have a lot of different encode. We could have the image as a JPEG, a TIFF, a BMP, a GIF, a GIF. I'm sorry, GIF. We could have it as it could be a movie. I mean, so the encoding I think is going to be a string. So what does that leave? So I've got so this could be a file system image would be file some a API might be oops. So again, right now we're just talking about images. We're not talking about media in general. We're talking about images specifically. I think this should be a MIME type. Let's go get the MIME types. Okay, let's start going through this. Skip that for now. Const MIME binary equals. Okay. All right. CD audio shell script, CSS. Nope. 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 GIF. Sorry, GIF. So we're good. There's JPEG. JSON, MIDI, MPEG. Okay. Video. Let's see, there's PNG. Ooh, I was forgetting all about PNGs. If you can hear my stomach growling, I am sorry about that. Could be a sphig. don't know if people actually say that, but Sfig sounds fun. Yeah, sure. I'm Flash. You know, I wouldn't want somebody to say, but you're condemning Flash to up. We're gonna lose all our Flash files. What was that called? MPEG transport. I don't know. I don't think that's. I don't know. Could be. WebM. I have no idea what these are. I don't think I've ever used them. XML, Zool, Zip. Sure, what the heck. And this was all right. So type mime type. And let's do this. There we go. Okay, so how would we get this? How do we get this? We would either know up front, like if it's an API, we would know up front because we maybe put it there or we get some metadata from it or something. Now let's say we were getting a result of 100 images and we had to go out to each of the sources and taste them to figure out what the MIME type was. That would become prohibitive, wouldn't it? So we're probably going to have to cache that or store that in some way that's reasonable. So metadata is about the same image. This is going to have multiple metadata results, right? So when we hit this query, it looks like my metadata table needs to also carry information about resolution and MIME type. So let's walk through this. So if metadata, so when I'm running this metadata service, I'm interfacing with the database. This is probably when I'm best going to be able to capture information about resolution and MIME type. Because at the end of the day, I could have something called foo.jpg, but it's actually a TIFF. So I can't rely on just the file name for the MIME type. But if I'm processing the images and I'm inserting new metadata into the database, chances are I will have immediate access to the image itself, and that's when I would taste it to figure out what kind of data it is. Then I would put that up as the resolution and the encoding. That kind of suggests that the metadata API here for the server is incomplete, that I need some sort of save something like that. And I'll tell you why I'm returning back the metadata from the save. So let's think about this for a second. So I'm inserting it into the database, or I'm saving it in some sort of database. That could result in, if it's a new one, some sort of ID being assigned to it, in which case I'd want to return back a copy with the assigned ID. So if I'm saving a new one, I'd expect the ID to be 0, the 0 value for int64, right? Maybe, well, let's do this. Let's have separate create and save. So create and save just returns an error. Why does it work this way? Because I don't want so if I'm creating new metadata, I'll always create a new ID, right? But if I'm saving metadata, I'm not going to create a new ID. So let's have two separate methods here. Create inserts new metadata, and we'll assign new ID to that data every time. Okay, so that's why we have those that way. Let's go ahead and add those two functions so we don't break our compilability or buildability. Let's go ahead and add these two functions in. Okay. So we've got the ability to save the data. We're going to need to add we're going to need to add and oh, by the way, let's go ahead and move this over to metadata where it belongs. And this will be a data. There we go. That makes more sense. Okay. And I think we should have, well, resolution isn't just an XY, right? Because we can have progressive and interlaced. Type resolution. So this would be the width in units. The scan So really what we need, so let's put a todo here. So really what we have here is an image, or sorry, let's not use the word image. So we have some bits on disk. They could be in multiple places, or they could be not on disk, but on disk, Amazon, whatever. But I'm talking about a specific image. So it's a 1024, or sorry, 1920 by 1080 JPEG. That's on the file system, and a copy of it is on AWS. If I grab the version from AWS, I expect it to be byte for byte the same as what's on my file system. And so they are metadata about the same actual image. If I have a thumbnail, that's a different bunch of data about which I have metadata. So let's be clear. If I have a thumbnail of a picture, let's use the word picture, that's better. If I have a thumbnail of a picture, those are two separate metadata records. One for the original picture, if I have a thumbnail of a picture, and a TIFF let's say a JPEG picture, a TIFF encoded version. Those are 3 separate metadata records, right? Okay. One for the JPEG, one for the TIFF, and one for the thumbnail, right? If the JPEG version is stored in 2 places, I still have 3 metadata records, or 3 metadata instances, but the JPEG one will have 2 locations. Okay, so given stream of media, each media may have each stream. Yeah, okay. Okay, so metadata will be the same if it's the exact same image. If, however, the image is different, like it's been re-encoded or a different resolution, then it is a separate metadata instance for each one. Okay, great. Image, on the other hand, is a higher level concept, right? So image is I have a cat. I have a cat. I have a cat eating a Beanie Baby that I took in 2019, and I created. I've got my original JPEG that I took with my camera. I've got my archival TIFF version. I've got a thumbnail. The archival TIFF version is in an AWS bucket. The JPEG is on this API. So in this case, I would have one image, and I would have a whole bunch of different sources for that image. And so I could then go in, and let's make this data.resolution. I could then go in and say, okay, I'm interested in the high resolution archival TIFF. Or I'm interested in the low resolution thumbnail. That makes sense to me. That makes sense to me. Let's go back down here. Just count that out. So, all right. Okay, I think that's enough for today. I think I've really clarified my thinking about this today, and I think I understand what I want to do better. So if you're wondering what I'm actually doing, so we might have lost sight of the end goal here. The end goal here is I want to be able to take the backups I have, go through all the images, and create some sort of archival representation of the images that I think are important to me and I want to keep, and I want to bring forward in time and be able to pass on to my kid, their kids, blah, blah, blah. And essentially, I'm creating a way to archive these images, and I would love to be able to say, yes, I have this image. This is the image location. It's we should probably also have resolution SHA-256 hash. So we should probably also have the hash so we know if any data's changed. But I'd like to be able to do is say I've got a picture of baby's first step. It exists in these places under these conditions at these resolutions, but it's the same thing. It's the same image. It's the same thing that I've captured. It's just in different places, and then be able to turn around and say, okay, what am I backing up? What is the world of things I need to back up? I need to back up the original JPEG. I need to back up the archival TIFF version, and if I create thumbnails, I may want to. I may not want to back up the thumbnails, right? But I might want to know that they're there because I might build an application over this where I go through and I say, okay, walk me through these pictures. So I have, low resolution thumbnail, high resolution thumbnail to show in the search results. All right, I'm getting there. I feel like I'm closer. All right, again, keep trying to leave, but that's it for today.